Hey guys, so for today I'm going to show you how to find the transfer function and the initial values from a state space using this formula. Okay, so the example question is, given a state space, this one here, find the matrices corresponding to this formula, find the identity matrix and then the inverse identity matrix. Find the transfer function, and then find the initial values, solving for x1 of t and x2 of t. Okay, so for our state space, the first thing we need to do, according to the question, is to identify each of the matrices. So our formula is C of S I minus A inverse times B plus D. So let's start alphabetically. Let's find the A matrix. The A matrix is minus 3, 1, 0, minus 8. Sorry, just 1. And minus 8. Our B matrix is our 1 and 3. Our C matrix is our matrix here, 1, 0. And our D matrix is just there. Okay, now that we have this, we can go ahead and find our identity matrix. So I'm going to break our identity matrix into 2 steps. So this is what we need to find. Let's just start with finding this. So an identity matrix, it looks like this. It gets bigger as you need it, but we only need a 2 by 2. So this is our I. Now we need to times it by S to get an SI. So we have times by S, S, 0, 0, S. Because when you times these by S, there's 0, and this is just S and S. Pretty simple. Now, to find our S of S, I minus A, we need to times our S identity matrix by our A matrix that we identified before. Sorry, not times, minus our A, which is minus 3, 0, 1, minus 8. So let's go ahead and do that. Very simple. It's S minus 3, 0 minus 1, 0 minus 0, and S minus 8. Let's rewrite that. S plus 3, minus 1, 0, and S minus 8. Oh, sorry, plus 8. There's 2 minuses here. Yep. Okay, so now we found our S, this first step, this one here. So now we need to find the inverse of that. So the way to find our inverse matrix is that this is actually equal to the adjacent matrix of S minus A over the determinant of A. So let's go ahead and find the adjacent matrix first. So that's very simple. It's this one, but these two terms are switched and the signs in front of these two are switched. So that's going to look like S plus 8, S plus 3, 1, and 0. Since we can't get a minus there, it's just there. Very simple. Now let's find our determinant. So, like this one, but we use our determinant formula, which is this term times this term minus this term times this term, which is S plus 8 times S plus 3, or the other way around, doesn't really matter, and then minus 0, but you don't have to worry about that. Well, you can expand this, just so you know, but we're going to leave it in this form because it's more useful for calculation. But I'm just going to write the expanded form just so you can, just so you know. Okay, so now that we have our determinant and our adjacent matrix, let's go ahead and write them all together. So we have, it's much easier to write it like this. S plus 8, S plus 3, 1, and 0. Then it would be to go ahead and straight away divide these terms by this or by this. So it's much better to leave it in this form because it'll be much more useful and much easier to go and find these next steps. Because if you wrote it, say, as this, and then you divided it by this straight away, it'd be very messy and it's just not as useful. Okay, so this, we could stop here, but I'm going to go and solve it just so we have it ready for our last step here. So we have it divided, so it's S plus 8 over S plus 3, S plus 8, 1 over S plus 3, S plus 8, 0 divided by this, but we can just leave that because we know it's going to be 0. And then S plus 3 over S plus 3, S plus 8. So let's go ahead and cross off the like terms, and we can rewrite the matrix to 1 over S plus 3 we can put this as just 1, this is 0, and 1 over S plus 8. There, so that's our A and B done. Okay, let's go ahead and find our transfer function. Also, just fix that there. So we're going to use this form here. So let's write our formula again so we can see what we're doing. So C times S I minus A inverse times B plus D. Okay, so let's write all our matrices again in our newly formed Si minus A inverse. So our C is 1 and 0 times our inverse. We're going to use this form here. So this form here. It's much easier to work with. S plus 3, S plus 8, S plus 8, 1, 0, S plus 3. Then our B matrix, it is 1, 3, plus our D matrix, which we had, it's just 0. So we can do this in a couple of steps so we don't get too overwhelmed with all the matrices and all the multiplications. So we're going to do just this B times the SI. So we have matrix multiplication, the 1 times the S plus 8 and times the 0. Then the S, then the 3 times the 1 and times the S plus 3. So let's go ahead and write it all out again with our multiplication. So 1 times S plus 8 is just S plus 8. 1 times 0 is 0. Then 3 times 1 is 3, and 3 times S plus 3 is 3S plus 9. Just like that. Now we go and don't forget all our other terms. Still times by S plus 3, S plus 8, and our other matrix, our C matrix, 1, 0. Okay, so we've done the B part. Now we're going to do the C part. We're going to times this by this matrix here to make it much easier. So let's just write it again with the C matrix on the other side so we don't get too confused. Okay, so now for this matrix multiplication, we times, oops, sorry, we're not actually finished with our matrix multiplication from the B. It's actually S plus 8 plus 3 plus 0 plus this, so our term is S plus 11 and 3S plus 9. Now we can times it by our C. And don't forget, we have our division here. Okay, now we can go ahead and times these two. So our 1 times this, the first term, and our 0 times the second. Our bottom term is going to be cancelled out completely, so we're just going to get S plus 3, S plus 8, S plus 11. There we go. Now we can rewrite that so we have our transfer function. We're going to get S plus 11 over S plus 3, S plus 8. Now it's fine to leave it in that form, or you can simplify it down if you'd wish to what we found over here. S plus 11 over s squared plus 11s plus 24. There we go. That's our C done. Now we need to find our initial values and solve for this. So now this is where this other matrix that we solved from before comes in handy. It's much easier just to write that matrix. So let's write it again. 1 over s plus 3, 1 over s plus 3, s plus 8, 1 over s plus 8, and 0. So what we do with this one here is, well, let's go ahead and write our initial values again, just so we can see it. x1 of 0, x2 of 0 equals 1, 0. So our x1 of 0 equals 1, and our x2 of 0 equals 0. And then solve for x1 of t and x2 of t. Okay, so it's very simple. We'll just use this formula. X of s equals part of our formula from before, si minus a inverse, which is our formula here, well, our matrix here, times by x of 0 plus b times our r of s. So we don't have to worry too much about that last bit, but we'll write our equation again. 1 over s plus 3 over 0, then our 1 over s plus 3, s plus 8, and 1 over s plus 8. Times our x0 up here, 1 and 0. Now we just need to use our matrix multiplication again to solve. So that equals 1 over s plus 3 and 0. So now that we have this, we'll put it equal to our x of s now to find our xt, we will inverse Laplace then we'll have our very easy x of t e to the minus 3t and 0. There we go. Those are our initial values done. And all the questions. There you go, guys. Hope that was helpful. Hope you liked it.